You can see there is a corner present on the right hand side also, so we have to provide chamfer here also. So this chamfer will be similar to this chamfer provided on the left hand side. Now we will see the dimension of this chamfer. Now in the question it was given as 6 into 45, that is this inclined line will be at an angle of 45 degree with the vertical, whereas the height of this line, vertical height of this line, inclined line, will be equal to 3 mm instead of 6. Now we will give the dimension so that you can understand. From this point to this point, the vertical height will be equal to 3 mm. You can see the vertical height is equal to 3 mm. So the vertical height of the inclined line will be equal to 3 mm, whereas the inclination of this line with the vertical will be equal to 45 degree. Since in the question it was given the chamfer angle is what, 45 degree. So now you can see I will give the angle. So you can see the angular dimension, that is the angle of this inclined line with the vertical, is equal to 45 degree. Similarly, we will provide the chamfer on the right hand side also. So now I am providing the chamfer on the right hand side. So you can see we have provided the chamfer on the right hand side also. Again we will give the dimension. Now the angular dimension of this line with the vertical will be equal to 45. You can see 45 degree, whereas the vertical distance from this point to this point will be equal to 3 mm. So the vertical distance of this inclined line is equal to 3, whereas the inclination is equal to 45 degree. So finally we have completed the front view of the jig plate with all the holes and chamfer provided inside it. Now we will show hatching line inside a solid part. Now you can see this is a hole, so this is a hollow part. Similarly, this part is also a hole, so a cylindrical hole, so this is a hollow part. This is also a hollow part since this is a hole, and this is again a hollow part. So we have to show the hatching lines only in the solid part. Now we will show the hatching line inside the solid parts. So this is a solid part. Again, this is a solid part. This is a solid part. This will be also a solid part, and this is also a solid part. So you can see we have shown hatching lines into the solid parts. Now we will draw the front view of this jig. This is the sectional front view. Now we will draw the top view of this jig plate. So for drawing the top view, first we will extend this center line in the top. Now you can see if we observe this jig plate from the top, this is a cylindrical part, so the top view will be circle. Now we can observe this largest circle. So this largest circle was of diameter 284, but in actual we have taken the diameter as 141. You can see I will give you the dimension here. The diameter of this part, actual diameter is what, 142. So here we have to draw a circle with diameter as 142 mm. Since this cylindrical part will be clearly visible from the top, so now we will draw a circle with diameter as 142. We are taking the center. Now I am giving the diameter as 142. Here the radius will be equal to 71. You can see I am giving the radius 71, half of 41. So this is the top view of the first part, or the outer diameter. So this outer diameter is drawn in the top view as a circle. Now we will draw, I will extend this center line little below. After drawing the vertical center line, now we will draw the horizontal center line. So you can see now I am drawing the horizontal center line. Now in the next step, you have to draw the top view of a circle which will be formed due to the chamfering. You can see chamfering has been done on the left hand side, right hand side, as well as chamfering has been done on the right hand side. Due to this chamfering, what we can see, if we observe this figure from the top, that is from this direction, we will observe the chamfer circle. So whenever chamfering is done, a circle is formed, that is the chamfer circle. So we have to show this chamfer circle in the top view also. Now before drawing the chamfer circle, we will see the dimension of the circle. So the diameter of the chamfer circle, that is the distance from here to here, you can see it is equal to 136. So the diameter of this chamfer circle, which has to be drawn in the top view, is equal to 136 mm. So now in the top view, we will draw a chamfer circle with dimension as 132. that is the radius diameter will be equal to 132 mm. So now marking distance 132. Okay, we'll select the diameter, and the diameter is equal to 132. So from this center we will draw a circle with diameter as 132. So the outer circle is of diameter 142, whereas the inner circle which has been drawn now is nothing but the chamfer circle, which has been provided due to chamfering of these corners, and it will be of diameter 136 as we have identified the dimensions. Now we have to draw this center hole. Now this hole, if observed from the top view, will be what? Circular, because it is cylindrical in nature. So the top view of this cylindrical hole will be a circle. So for drawing this circle, we know the dimension. The diameter of this hole was equal to 64. In the question it was given 64, but we have taken as half of 64, that is 32. So now here we will draw a circle of diameter 32 mm. So this is the top view of the cylindrical hole which is present in the center. Now in the next step we will draw the top view of these holes. Now these holes are total 6 in number. You can see from this figure the total number of holes provided for inserting the bush is what? 6. So in order to draw these holes, we have to mark the center of these holes. So for drawing the center, we have to first draw this pitch circle. You can see this circle, this is nothing but the pitch circle. So the diameter of the pitch circle was equal to what? 204. But we have taken, instead of 204, we have taken as 102, half of 204. So now we will draw here in the top view a pitch circle of diameter 102. So from the center we will draw a pitch circle of diameter 102 mm. So this is a circle on which the center of the 6 holes will lie, that is these holes. Now the diameter of this hole was given as 32 mm. What? 32 mm, that is these holes. But instead of taking 32, we will take it as 16 mm. So from this center you have to draw a hole of diameter 16 mm. So this is the top view of this hole, that is the first hole. Similarly we will again draw the hole on the left hand side also with diameter as 16 mm. Now you can see, now we are drawing here the hole of diameter 16. I will give you a dimension here so that you can understand diameters. This outer diameter was equal to 142. The diameter of this chamfer circle was equal to 132. Okay, there is a mistake. You can see from the front view the diameter of this chamfer circle was equal to 136, but we have drawn here a circle of diameter 132. So we will change here, we will delete this circle. Instead of 132 we have to draw a circle of diameter 136 in the top view. So now we will draw here a circle of diameter 136. So this is the chamfer circle, and we will give dimension. Dimension is equal to 136 mm. Now the diameter of this hole, actual diameter was equal to 32, but due to half scale we have taken as 16 mm. So you can see I am giving a dimension. The diameter of this hole will be equal to 16 mm. Now we have to draw 4 more holes of similar dimension. So now we will draw the holes one by one. Now I am reading the dimensions. Now since there are total 6 holes, the angular distance between two successive holes will be equal to 60. Since the total angle of a circle is equal to 360 degree and there are 6 holes, so we will divide 360 by 6. So we will get the angular distance between two successive holes. That is 360 divided by 6 will be equal to 60 degree. So now first we will draw the center lines for the remaining holes. So the first center line will be at an angle of, the first center line will be at an angle of 60 degree. So now here we will draw a line at an angle of 60 degree. Now you can see this inclined line is at an angle of 60 degree. Now we'll give the dimension. You can see here. So I will give the angular dimension so that you can understand. You can see the angular distance between this center line, that is the center of the first hole, and the second center line is equal to 60 degree. Similarly, we have to draw the next center line at an angle of 120 degree. Now you can see I will draw the next center line, or we can take the angle of 60 degree from this line, that is this horizontal line. From this horizontal line we will take an angle of 60 degree on the left hand side. Now we will check the angular distance between this line and this center line. So we will give the angular distance, it should be equal to 60 only. So you can see the angular distance between this center line and this center line is equal to 60 degree. Now we will delete this extra part from the center lines. Similarly, now we have to draw the lines inclined at 60 degree in downward direction also. So what we will do, we will just extend these center lines. You have already drawn line at 60 degree on the left and line of 60 degree on the right. Now we have to extend these center lines in the bottom direction. So now we will extend this line. So you can see I am extending. Again I will extend this line in downward direction. So you can see finally we have drawn all the lines at an angle of 60 degree. Now we can check the angular distance if you want. See, this angle is again 60 degree. The angle between this center line and this center line will be equal to 60. Similarly, the angular distance between this center line and this center line will be what? 60. Again, the angular distance between these two center lines is equal to 60. So in short, we can say the center line of all the holes will be at an angle of 60 degree with respect to each other. Now I am deleting these dimensions. We will give it later on. So finally we have got the center of all the holes. Now we will draw the top view of the holes. That will be nothing but a circle of diameter 16 mm. So here we will draw circles of diameter 16 mm. Second circle. Again we will draw circle of diameter 16 mm. Again with this center we will draw a circle of diameter 16 mm. 16. Again with this center we will draw a circle of diameter 16 mm. Diameter is equal to 16. Again with this center we will draw a circle of diameter 16. So you can see finally we have drawn 8 holes. 1, 2, 3, 4, 5, 6. Sorry, 6 holes in the top view. And these are the circles which represent the top view of these holes. Now in the next step we have to draw the top view of this hole. That is this hole which is provided for providing a seat for the head of the cap screw and internal threading which is provided at the bottom portion. So now we will draw the top view. For drawing the top view, now the top view of this cylindrical hole will be a circle. Now the diameter, actual diameter of this hole in the question was given as 22, but we have taken a reduced scale, so we have taken a diameter as 11 mm. So now we will draw in the top view a circle of diameter 11 mm. Before that, we have to extend the center line in the top view. So now I am extending the center line. To extend the center line in the top view, so we have extended the center line. So this will be the center of the hole in the top view. Now we will draw the top view of the hole. So the first hole will be of diameter 11 mm. The actual diameter is equal to 22, but we are taking half distance, so we will take as 11 mm. Now you can see I will give a dimension. The dimension of this hole is what? 11 mm. Now in the next step we will show the internal threading which is present in the lower part of the hole. Now the internal threading, the major diameter of the internal thread was equal to the 16 mm, whereas the minor diameter was equal to 14. So instead of taking 16 and 14, we have taken 8 and 7. Half of 16 is 8 and half of 14 is 7 because of reduced scale. So now here we have to draw two circles. One will be of diameter 8 mm and second will be of diameter 7 mm. So here we will draw two circles. One will be of diameter 8 mm. Okay, this will be first circle will represent the minor diameter of the thread, which is equal to 7 mm. So this first circle will be of diameter 7 mm. You can see I am giving a dimension. So you can see dimension. This inside circle, which represents the top view of the minor diameter, will be of diameter 7 mm, whereas the major diameter of the threading will be equal to 8 mm. For major diameter, you have to draw dotted lines. So whenever we represent the internal threading, the inside circle will be dark since it will be visible from the top. But for the outside circle, it will be hidden circle. And its diameter, the diameter of the hidden circle, that is the diameter of the circle which represents the major diameter, is equal to 8. You can see here. So we have drawn three circles. The outside circle is of diameter 11 mm. Then two internal circles, one circle representing the major diameter is equal to 8 mm and the other circle representing minor diameter will be equal to 7 mm. So finally we have completed the top view of the jig plate. So this is the front view. This was the front view of the jig plate, whereas this is the top view of the jig plate. Now you can see we have given it diameter as figure. So you can see we have completed the sectional front view and top view of the third part, that is the jig plate. So this was the front view and top view of the jig plate. Now we'll give the dimensions one by one. Before that I will draw a box outside it. Now we will give the dimensions one by one. So this diameter in actual, in the question it was given as 284. So instead of 142 I will write 284. Now the height, the actual height of this part of the jig plate is equal to 32, but we have drawn it with as 16 mm. So here we will replace 16 by 32. You can see I have replaced 16 by 32. Now the center to center distance from here to here, the distance from here to here was equal to 204, but due to reduced scale we have taken it as 102, but while giving the dimensions we will give it as 204 only. Now we will give the diameters of the hole in the top view. So the diameter of this outer circle is equal to 284, which is it is already given in the front view. Now we will give the diameter of these holes. Now the actual diameter of this hole was equal to 32, but due to reduced scale we have taken as 16, but while writing here we will take it as 32 only. So we have to write here diameter as 32. So symbol diameter phi 32. Now the diameter of this hole at the center is equal to 64. Phi 64. Here also we will insert the symbol phi for diameter. So phi diameter as 64. Here also we will insert the symbol phi 204. Now the diameter of this hole which is present at the center is equal to 64. The actual diameter was 64. So we will give the diameter as 64. See, the actual diameter is 64, but due to reduced scale we have taken the distance as 32. So now we will write here the actual diameter as 64 only. Now the height, we'll give the height of the hole. Now the height of this part, you can see the height of this part is equal to 5 mm, but in actual the height was equal to 10 mm. In the question it was given as 10 mm, so we will give the dimension as 10. So the height of this upper part is equal to 10 mm. Now the major diameter of the thread here, the major diameter from here to here was equal to, the actual major diameter was equal to 16, but we have taken 8 because of half scale. So now we will write here 16. So the major diameter M, you can see, is equal to M16. So the major diameter of the thread is equal to 16 mm. Now the last distance that we have to give is the dimension of the chamfer. So you can see this vertical height is equal to 3, but actually it was equal to 6 mm. The dimension of the chamfer was given as 6 into 45. So we will write here 6 into, dimension was 6 into 45 degree. So we will insert the same word. So you can see the dimension of this chamfer is equal to 6 into 45. Okay, we will use the dimension on the right hand side since it is not visible on the left. So you can see I am giving a dimension here. Dimension of this chamfer will be, actual dimension is 6 into 45. Since the question it was given 6 into 45 degree. So we have given all the dimensions. So this was the sectional front view and top view of the third part, that is the jig plate. Now we will move this entire, okay. So finally we have completed the sectional front view and top of the jig plate. In the coming sessions we will complete the top view and front view of the remaining parts, that is the bush and the latch washer. Here I will write front view, and in the top we will write the top view. So finally we have completed the sectional front view and top view of the third part, that is the jig plate.